All right. So here we're still in chapter 4. I did post some videos on YouTube yesterday, excuse me. So here what we're looking at in chapter 4 right now, normally we're looking at percents. And today what we're going to consider is absolute change and relative change. That's what we're going to see today. And I did present the definitions last time. I just feel better going through them again. So basically, if you have a quantity that changes value, there's this notion of absolute change and there's relative change. The absolute change, that's the ending value minus the starting value. Again, that's just the definition, okay? That's just the ending value minus the starting value. And the relative change, by definition, it's the absolute change divided by the starting value. That's what it is, again, by definition. The relative change is actually what you have before you have percent change. In other words, if someone's asking you, what's the percent change in this, or by what percent did something increase or decrease, you basically calculate the relative change, and then you convert that to a percent. And remember, to convert it to a percent, you move the decimal point 2 spaces to the right, which is really the same thing as multiplying by 100. I mean, we will see some example. We'll see an example or two today. Also, this has come up before, excuse me. When we subtract or add percentages, the units that we use are called percentage points. So like 10% minus 5% would be 5 percentage points, or 8% plus 2% by definition would be 10 percentage points. That's just the units that people use I think it's just the definition. I just wanted to point that out also. I don't remember if that came up in Math 151, this class I mean, but still I feel it wouldn't hurt to know. I think it's mentioned in the book also. All right, so let's now do an example. So let's say, I'm at the gym or whatever, the track on campus, which I've been to usually over the summer. I like to run for fun. But let's say one week I ran a total of 25 miles. And then the next week I ran 28 miles in total. Okay? Calculate the percent increase in the total number of miles. So the percent increase. Okay, so what we want to do is basically get the percent increase, which is the percent change. So we do have to get the absolute change, okay? For relative change, for percent change, we first calculate relative change, and then we convert it to a percent. So we have to calculate absolute change. Okay, well, the starting value here is 25 miles. That's the beginning. And then the ending value, right, is 28 miles, right? The total number of miles starts at 25 miles, ends at 28 miles, right? And we want to know what is the percent increase in this. What is the percent increase? Okay, so we have the starting and ending value. The absolute change then is 28 miles minus 25 miles, which is 3 miles. Okay, 3 miles. So that's the absolute change. But to get the percent change, we do this. We have the absolute change, which is 3 miles, over the starting value, which is 25 miles. All right, 3 miles over 25 miles. And if you do that in your calculator, you get 0.12. So as a percent, that's 12%. So the percent change, the percent increase is 12%. So the total number of miles I run increased by 12%. So the first week I ran 25 miles. Then the next week I ran 28 miles. The total number of miles I ran increased by 3%. Excuse me, by 12%. So that's really what this is asking. Okay, so again, we got the starting value, we got the ending value, right? We got the absolute change. Then we divided by the starting value. So I'm calculating relative change, and that's 3 miles over 25 miles, which is 0.12. As a percent, you move the decimal to the right 2 spaces, 12%. Okay, so again, that's what we get. It increased by 12%. All right, so that's our first example. Are there any questions on this? Okay. Here's another example. Let's say the value of a car dropped, decreased from $8,600 to $7,300 over the last year. So the car initially valued at $8,600 decreased to $7,300 over the last year. Let's calculate this percent change. So it's the same idea. We're going to calculate relative change, then we're going to convert that to a percent. So the starting value, the starting value is $8,600, as you can see. The ending value is $7,300. Okay? Okay, so what's the absolute change? Well, again, that's the ending value minus the starting value. So which is this difference, which is this. It's negative. That's expected, right? Because the value dropped. So we expect a negative number for the absolute change. And then for the relative change, we have the absolute change divided by the starting value. So we have negative 1,300 divided by the starting value, which is 8,600. And if you did that in the calculator, you get about this. And then we round it to 2 decimal places and convert to a percent. So we get negative 15.12%. So the value of the car decreased by about 15.12%. The negative tells us that it decreased. So it is possible to get a negative value. That can happen, okay? It's not like over here in the previous example where the total number of miles we ran in a week, or I ran in a week, right? Here it increased. So our percent change was positive, whereas, here it decreased. So we expect a negative value. Okay, are there any questions on this? Okay, so now what I want to do is introduce to you a new kind of function. We saw in the previous chapter linear functions, and those, remember, are functions that just basically look like straight lines when you graph them. Well, excuse me, non-vertical lines, I should say. In other words, you can write them algebraically. Excuse me, a formula for them algebraically is given by this. You have f of x. F is notation, remember, for the function. X is your input. F of x is the output. And that's given by this. Where again, m is the slope. B was the initial value where the graph crosses the y-axis. And remember, what does slope really equal? It's the rate of change. But the idea there was if you were to increase this x, the input, by 1, the function values are going to change by m units, no matter what, and for any x. So no matter what x is for a linear function, if you increase x by 1 unit, right, the output will change by m units. The change in output, which is this, will equal that slope. But I'm going to show you now a function that's not linear. That is, this is not going to happen. All right, let me just take care of the recording. Okay, this is a little strange what I'm doing now, okay? So again, if you don't understand it at first, don't panic, don't be afraid. This stuff's not easy. I know it isn't, okay?